Good morning. Welcome to Data Science and Telecom. We're going to go over some use cases. I'm going to give you a little bit of background on data science, and I think you'll enjoy this workshop. My name is Dr. Frances Boykin. I work for AT&T. I'm a director of advanced analytics, and I've worked in numerous organizations within AT&T, including global supply chain, customer experience, digital insights, as well as marketing. And so I'm going to kind of try to bring all of that experience together to give you an idea of some of the things that we have used data science for at AT&T. As a matter of fact, I'm going to go over specifically a project that we did within global supply chain and also talk to you a little bit about some of the projects that we've done in customer experience. I do want to say that I don't have a lot of hands-on activities for this particular workshop because it would be hard to bring in a lot of the data that I would need for a work hands-on, but definitely I'm going to open it up for you to ask some questions so that we can specifically talk about any of the interests that you have within your own organizations with using data science. So I'm going to share my deck really quickly. I'm going to share this screen. Oh my, there's an echo. Okay, I'm going to try that one more time. That doesn't seem to be working. All right, can you put in the chat whether you're hearing an echo? Okay, so it does seem to be that there's something going on. Okay, yes, you can hear the echo as well. I'm not sure what's going on. I didn't hear an echo, and then all of a sudden it started. I'm going to see if I change. Give me just 1 second. Can you hear me? I still hear an echo. Give me a second and I'll see if I can find a set of earphones to add. I honestly don't normally have the headphones. Let's see if this will work. Can you hear me? Can someone put in the chat if you can hear me? Okay, so it says it's still. How about now? Okay, awesome. So let's see if I can share. Okay. How about now? How about now? Awesome. Can everyone hear me? And you're absolutely right. I had multiple tabs open, and that is why that was happening. So let's go ahead and get started. Okay, so data science in telecom. Let me try one more time to change where I am sharing from. Let's see. I'm going to try to share one more time. Going to share one more time, and then I think we should have it. Okay. Okay, so I am hoping that you are seeing the data science and telecom screen, and it should be full screen. And hopefully that's what you're seeing. Unfortunately, with the way Crowdcast is set up, I'm not able to see your messages. I'll have to go out of full screen in order to see your messages. So here we go. So data science and telecom. So again, my name is Dr. Frances Boykin. I'm Director of Advanced Analytics here at AT&T. And we're going to talk about all of this rich data that we have within telecom and how we use it today at AT&T and telecom, and how you can use it in your own organizations. And as the slide here shows, we're talking engineers and analysts using this data. There's so much data around telecom and service and sales and information and customer experience and retail as well. So machine learning itself is the science and art of programming computers so they can learn from data. And as I mentioned, we have so much data in telecom. And data science is the science which uses computer science, statistics, and machine learning, visualization, and human computer interactions to collect, clean, integrate, analyze, visualize, and interact with the data to create data products and services, as well as information about those products and services. So if you've seen anything in the last few years, you've seen that there's so much data out there. The World Economic Forum in 2011 said that data is the new oil. So you just have so much data. 247 billion emails. You have just a plethora of data that's coming across from blogs and social media. This slide talks about DVDs. We all know we're not using DVDs much anymore, but just think about Netflix and Hulu and all the data that's coming across Amazon. All of that data is now available for us to use. So what is big data? Big data is it's a noun that represents extremely large amounts of data. So these large data sets that we now have available to us that we can now use to build out information. So we're looking at raw data, the volume of the data, the velocity of data, the variety, the different data types, the veracity, the quality of the data, and then the value of that data to be used in information for decision making. And this is the 5 V's of big data. Most everyone has heard about this, but the most important thing about big data is that it is huge, a huge amount of data. Some of it readily available for us to work with. Other data we have to massage and bring it together. But now today we have the computer power, we have the know-how, we have the application power to bring all of this data together so that we can build out great insights. So there are so many computational methods that we use in big data for aggregations, graphical models, linear algebra, optimization. And here's a list of those. For querying data, getting to nearest neighbor, what information represents the categories that I'm interested in using and using as delineators for the information I'm trying to get to. Regression, building out those regression analysis and classification, again, with nearest neighbor. Outlier detection, anomaly detection, determining fraud by looking for outliers and anomalies in the data. That is all big data used with big data now. And these kind of methods are important for us to move forward and building out different ways of working with our data. Clustering, building out hierarchical ways of looking at the data. We saw this when we built out Facebook and friending and all of that cool stuff. We also see it even, for example, when we go to Amazon and we see things like, hey, you've ordered this and people like you are ordering this other thing. Why don't you order it too? We're using a lot of that. Time series analysis. We use this quite often in global supply chain. And then feature selection. I'm going to be talking about some cool stuff that we did here at AT&T that's actually in the news right now around feature selection. And then, of course, all your sample testing and matching. I'm going to go stop sharing just to check the messages real quick and make sure everything's good there. All right, awesome. I just wanted to check real quick because I can't see that while I'm sharing. And I will go back to sharing. Give me just 1 second. And so, as I mentioned, we have so many ways of computing and massaging this data and building it out into something that helps us build insights. And one of the main things around data science that a lot of people kind of miss in the whole beauty of data science is the fact that it's important for us to understand that data for the sake of data is not the goal, our goal. It's building out the insights from that data and using these algorithms, using these computational methods, and grabbing all of that data and then mapping it together so that it builds something that we can then make actions on, or actionable insights on, is what's important. So let's talk about the path to what we call predictive analytics. So many people are really working today to get out of hindsight, which is reporting, that static reporting and dashboards and alerts. Now, that's not to say reporting and dashboards and alerts don't have a place in our daily work lives. It's just that if you're moving past that to get to insights using data mining and then getting to the foresight, which is that predictive and prescriptive analytics. So moving up that ladder there. Now, as you can see from this graph, this is one of my favorite graphs. I've been using it for years. And it talks about the complexity, the business benefit, and then the time it takes to get there. And you'll notice that building out those reports pretty quick. Getting past that and getting to the predictive analytics, you're getting more benefits. There's higher complexity, but it does take more time. So, what are some of the use cases and challenges in telecommunications? So I like to look at this from three perspectives: the customer, service, and resource perspective. And then look at it across the top here. You see infrastructure and products, and then operations. And look at the different things that you can do using big data in telecom to build out these specific areas. Product recommendation. I talked about Amazon. Amazon is like all on top of that. And we're even using that within AT&T to be able to, let's say a customer calls in, you want to, in the customer service rep, there's so many products and services out there. What's the best one for that particular customer? Based on that customer's profile, what should you be offering that customer? That's a great use of big data. It's a great use of machine learning to help you really pinpoint what I should be offering that customer. And we called it next best action back in the day. Oh my gosh, 10, 15 years ago, it was called next best action. And now we have like built that out into a whole new level of modeling to be able to provide that predictive recommendation. As a matter of fact, I'm going to show you a great example of how we did that in global supply chain and retail. So look at the operations side for customers, churn analysis and prediction. Some of the things that we've looked at AT&T is how do we predict whether or not a customer is going to be for us or against us? So everybody probably has heard about Net Promoter Score. So who are going to be our promoters and who are going to be our detractors? And how can we predict and then slide in there before a customer becomes a detractor to kind of turn that situation around? So churn analysis and prediction around that and proactive customer care, that's really, today, that's my job. I work for customer advocacy at AT&T, and we do a lot of this. And this is one of my favorite topics, obviously, since I work in that area. But looking at who's going to leave us, but not just who's going to leave us, but also who's going to leave us really mad and not necessarily be our best promoters. And so that's what we're looking at today and building out that proactive customer care. So what you can do is you can take the data and model that data around their calls, their credits. Have they had to call in multiple times? Have they had to receive a credit because there was an issue with their billing on multiple occasions? Are they getting good service on our network? All of those things can be pulled together to actually help us predict churn, as well as whether a customer will be a promoter or a detractor. And then you can actually build out proactive customer care interventions. Whether that's offerings, whether that's communications, whatever that might be, you can build that out and interject there so that you can build in a good customer experience. So let's talk about service, data monetization. One of the projects that it was recently in the news, and I was so excited to actually have been a part of it, not realizing that it was going to be in the news, is a feature store project that I actually worked with our chief data office on. And it was an awesome project where we were able to provide what we call customer journey data over to this project. And then our chief data office was able to build out what we call a feature store, which provides all these bits and pieces, and I use bits and pieces of information related to the customer's journey through the use of our products and services. And we've been able to monetize that at AT&T. So it was in the news recently. You can go take a look at it. Mark Austin is the person that I worked with, and he was actually mentioned in that news article. So also, we've used big data to help us with fraud management, pulling in all of that data and then being able to look at the anomalies and outliers to help us with, hey, is this something odd? So let's dig a little bit deeper into that. And then once you get that kind of information, you can go back to the proactive customer care and dig a little bit deeper there. Ordering process and optimization. I'll admit, this is not my bailiwick, but I was part of the global supply chain team that was also responsible for building out our networks as well as supplying our retail stores. And one of the big projects that I helped someone stand up as part of that was a process to help us understand which widgets we needed to get and have available and when we needed to have them available. Before we were able to use machine learning and big data techniques, we could only look at a certain amount of data at a time. In all honesty and transparency, we were doing it using Excel and Microsoft Access, which of course had data limits, and we weren't able to crunch it. It would take my counterpart weeks to pull together all the necessary data to say, hey, do we have all of the widgets we need for our orders? And once he came onto a project with me and I supported him in building out some market basket analysis, and he was then able to, for the first time ever, be able to build out a report that showed, hey, we have 50,000 orders. Some of them need widget A, some of them need widgets B and C. This is how they coordinate together. And this is how we make sure that we optimize that ordering process to make sure that we fulfill all of these orders. This was especially important when we had the pandemic that kicked off back in March of 2020, and we realized that we were going to have delays in some of our widgets. So this was so important that we had this in place, because we were then able to say, okay, these are our most important orders, and we need to, with the widgets we have available to us, we need to service these orders first, and these are the orders that come after that. We had never been able to do that before. So machine learning and big data allowed us to be able to do that. And then resource. Let's go down to resource, network planning. That whole ordering process and optimization works directly back with network planning. Network planning was important for, especially during the pandemic, because we needed to understand where we needed to ensure that we had optimal network or where there were some sort of issue. Capacity planning, more of the same, and then fault management and root cause analysis. And in my opinion, this is one of the hardest ones for us to work through and manage. Fault management and root cause analysis is really tough, because you can dig and dig and dig, and where do you stop digging? But machine learning, what's cool about machine learning and data science is that you can pull so much data together and you can let the machine chug through all of that and at least bring you back the top of the line where you should start looking. And then, so that you're not just boiling the ocean and sifting through sand. So that's the really cool thing about those two pieces: infrastructure and products, and then operations, and then the three areas that are important in business. And so what are the use cases and challenges? And specifically, what are the projects around those use cases and challenges? So customer loyalty, acquisition, and retention. I think this is probably the main thing that everybody is already very aware of. Customer churn. Everybody knows about churn. Everybody's been doing churn analysis for a very long time. The cool thing about machine learning and data science is that we can now do this at a finer level. And not only can we do this at a finer level, like I mentioned earlier, being able to look ahead at who these people are that are churning, and then look at what are our opportunities or options that we can use to stop the churn process, but not only that, save our reputation with these customers. So, and that brings me to the next one, which is sentiment analysis. And with sentiment analysis, we want to make sure that that we understand how our customers think, what they think about what we're doing, and how they feel. Sentiment analysis is so important right now. And that ties right into clickstream analysis. How do we understand what our customers think and how they feel? Clickstream, getting that data across our social media platforms and bringing that data in, what they do on our apps, bringing that data in as well, and then building out targeted marketing, customer segmentation, profiling, and recommendations, and optimizing those plans. I'm going to go off full screen just really quick. All right, awesome. Just wanted to check and see if there were any questions in the chat, and it doesn't look like they are. So I'll go back to presenting. Okie dokie. So, data driven improvements of our network. I talked a little bit about this network performance and optimization. Man, there's so many really cool things that we can do around this. Optimizing call routing. We're even working on a project right now specifically around call routing. And with the pandemic, you know that a lot of people in our call centers went home. We're kind of starting to come out of that a little bit, but we also realized through that situation that we had an opportunity to build out some better call routing through our IVR systems, using chat, online chatting. So if someone starts in online chat, the best option is to finish that whole scenario in online chat. But we all know, in all honesty, sometimes you have to move out of chat and go to a full-blown call, and sometimes you might even have to be sent into the retail center. So how do we optimize call routing to minimize what we call friction and effort from our customers? So this whole thing about real-time CDR call data analysis, that is a tough one. That is so exciting. That is something that we at AT&T are very excited about. And the fact that we can now pull so much of these call detail records together so that we can do that analysis. But to start doing that real time, we all know that's like chef's kiss. That's where we really want to be. But that's tough because we're talking about a lot of data. We're talking about a lot of data coming in really fast. So those are some of the cool things that we can do with big data in telecom, adding machine learning and AI on top of it. I will admit at AT&T, there may be some great projects around this, but I have not been involved in any of those. I've been involved in conversations about how we can get there, but not necessarily any live, hey, boots on the ground, we're getting this kind of thing started. I do know that we are looking at some tools to help us with real-time work. In my opinion, here at AT&T, that's our next step, real-time. We do a lot of near time, meaning within the last 24 hours, but very, very little at real time. So we want to start working with that sort of data. Capacity optimization, demand forecasting. Again, that was something that I was privy to within global supply chain. My counterpart, I have a cool guy that I work with, Isaac Osabute, and he is like, all on top of this. And it was so exciting working with him. We kicked off a project using Aster to work on forecasting. And I learned so much from him on how forecasting, the two ends of forecasting and how they come together and all of that good stuff. But really good opportunities with big data there. And then anomaly detection. I don't think I have to elaborate too far on that. We know that that's been something that we've been using quite a bit, especially in fraud. And then GIS location data monetization. We have talked at AT&T as well as some of the other groups that I've been involved in. And the exciting part about understanding where customers are, their location, and how we can send them, for example, let's say a customer is going by store ABC. And as they drive past store ABC, saying, hey, we have a red light special or blue light special. I don't know, blue light special. If you remember the old Kmart, we have a blue light special. Come on in and we'll give you 25% off if you are looking for XYZ at this time. So blue light special is what we really want there. And but GIS location data monetization allows you to be able to do that. Security, fraud detection and prevention, anomaly detection, false and answer and long call detection, lots of great things there. In telecom, I don't know if you've had this, but so lately I've been getting calls that are actually real people's phone numbers that are actually these folks that are trying to sell me something, usually in car insurance. But it's really interesting that they're able to utilize real telephone numbers to get you to answer the phone. So I think fraud and detection and prevention of those sorts of things would be something cool to work on. Payment processing, I've not been privy to any of those types of projects. Data protection and compliance, we all know that we have been focused on that for years and years and years. And I actually had a conversation with someone recently, and they were we were sending out a survey, and they wanted to put in a security portion of the survey to see what our customers feel about security. And when it came back, of course, security was not where they thought it should be. They were like, I thought security would be at the top of the list, but it's not at the top of the list. And I reminded them, in this day and age, we expect security. We shouldn't even have to think about security. Our expectation is that in this day and age, every organization takes security as a top priority. And as a customer, as a consumer, I don't have to worry about that. So that's why I think that it's not top of mind for many folks. So moving quickly, data science development life cycle. So if you're developing a project, data science project, I'm going to quickly go through this so that I can get to some of the other good stuff. Business understanding, number one, you have to have someone that understands the business. Data mining, understanding the data, cleanse that data, number three. Then number four, do some data exploration. Get a feel for what that data it really looks like and what it's actually saying. And then feature engineering. I mentioned that project through our central data, our data office at AT&T CDO. Feature engineering is important. Understanding the correct attributes that you need to use for your modeling and your data science project. Because in the past, way back in the day, well, really not that long ago, I would say a few years ago, I would say, well, hey, give me all the data and let's kind of see what falls out of it. Well, we all know about PCA and finding out the right attributes that you need to use so that you don't muddy the waters, send yourself down rabbit holes. So doing that feature engineering to me is integral in ensuring that you have a good model, because that's going to ensure that you have something that's clean, that it provides the important features that you need to be looking at as far as the data is concerned. And then build out your predictive model. Build your model based on a good foundation of the attributes that you need in the model, and then visualize that data. Data visualization, that you could do a whole class on just data visualization. And I have been to some of those classes because in all transparency, data visualization was my Achilles heel. I wasn't great at it. I ended up getting a couple of books that really helped me, and I keep those books nearby. One of them is Storytelling with Data, and the other one is The Big Book of Dashboards. I love those two books. Those are my favorite books. I think I have my book right here. Yes, I do. And those are my two books. Storytelling with Data is by, let's see, what's the name? It is by Cole Nussbaumer. This is an awesome book. Just that's the book that really has helped me. And again, the Big Book of Dashboards, I keep them right here at my desk. The Big Book of Dashboards, Visualizing Your Data. This is an awesome book as well. This one is by Steve Wexler, Jeffrey Schaefer, and Andy Cotgreave. But those are the two books that I use. I keep them by my side when it comes to data visualization, because that's not my bailiwick. So let's talk about a use case in artificial intelligence and machine learning that I did within global supply chain. And I'm going to go out of full screen. So I want to be able to see if there's anything awesome. So I don't see any questions, so I'm going to pop back in, but feel free, if you have any questions, pop them in the chat. I will pop back and forth. There you go. So nothing in the chat. So I'll pop back over. So let me let me go ahead and talk to you about this use case. So I told you about a big project that I had a couple of years ago. This project, we wanted to look at inventory planning, warehouse logistics, and device distribution. We wanted to look at that together. And as we looked at it, we realized that, hey, how can we ensure that we plan properly, have what we need in the warehouse, move it properly to the right place? That's what this project was all about. And we looked at the different kinds of analytics. We went through, in all honesty, the first three: descriptive and predictive, and then we did a little bit of prescriptive, and I'll show you what that looks like. But the descriptive piece was just kind of playing around with the data, seeing what the data, doing some histograms, looking at the data real quick, and then we did build out some a predictive model. And then we took that and we were able to then push it out and help us look at what we could make different, do differently in the stores themselves. Cognitive analytics, I won't go into that because I don't have time today, but we are working on that as well. How might we improve or optimize all of what we've done using the descriptive, predictive, and prescriptive analytics? So I'm going to pop on down because I want to jump in real quickly to what it looked like when we started out this project. We wanted to identify the data triggers. We wanted to be able to plan individual store device inventory needs. So we had to build out a model and then use that model in the planning process to provide guidance on which devices are most likely to be purchased at which stores. And we developed, as a part of this process, we had to develop an analytical working environment because at the time we didn't have one in global supply chain that would allow us to do big data analytics. We built out structured and unstructured data, and we pulled it together with a group of folks to work with us. So again, what did we pull together? We pulled together the who, the demographics, the what and the when, their purchase history, and the why, the campaign history, and then the where the store profiles. So we pulled all of that together into a big data environment. In this particular case, we pulled it into Aster. So quickly, we had 5 phases of the project: big data plan, data analysis, data environment, build out that model, and then integrate that model into what you do day to day. So I'm going to skip a little bit quickly through this because I want to make sure I get to the good stuff. We already talked about the who, the what, the when, the why, and the where. Again, I built that into an Aster database, but here's what that looked like. We built out a profile of customers. So we grouped our customers by demographics and pulled that information together. We then profiled our stores. We looked at a group of stores. We wanted to group them by their demographics as well. And then we created a relationship between the customers, the purchases, and the stores. And then we used that result to determine the probability of device purchases by store. Okay, what did we use? We used collaborative filtering. So we leveraged predictive analytics using the collaborative filtering model or recommendation engine. So what does that look like? Input, that's all of our active information was our input. And then if you know anything about the algorithms, there's a specific algorithm. I love to put this on the screen and then say the lovely thing about Aster is that you don't have to know this. You don't have to know the Hofstede model. You don't have to understand the cultural distance matrix or be able to calculate the similarity matrix. You don't have to do any of that because guess what? There is a specific algorithm in Aster to allow that does this, and it does it in seconds. So literally, I type that in, point it to my data, and it would actually run this collaborative filtering algorithm for me, which was awesome. So if you're interested in knowing it, I wanted to put it on the screen, but you don't have to. And in most languages, you don't have to. Whether that's Aster, Vertica. Now we're moving into the cloud, of course. So we're using lots of data solutions there to help us. So what did we find out? What we found out is that we had stores that were near each other that didn't necessarily sell the same things, and that was really key, because for us, what we recognize is that we, in our planning process, we would say, hey, let's take, marketing would say, we're going to sell 50,000 of these, and we'd say, we got 2,500 stores, let's split those out amongst the stores. The bigger the store, you get a few more. Smaller stores, you get a few less. But what we found is that we would have some things that anybody in global supply chain doesn't like to hear, and that's called stranded inventory. That means inventory that's in a store that can't be sold because there's no interest in that location. And especially when you're selling telecommunication items like cell phones, what happens? The next cell phone comes out, you don't need all that old stuff. So it becomes stranded inventory. And that was costing our stores money. So what we want to know is, hey, which stores are most likely, which customers at which stores are most likely to purchase these items? And then what we can do from there is we can now stock our stores that way. This was an awesome project. Full transparency, I did this project by myself. I was a team of one. But the cool thing is that when I finished it, was able to provide and test the model itself, I was able to then take my project, hand it off to our chief data office, and they took up the project, and then they put the oomph behind it to push it out across AT&T. So what we did was, in order to test it, I built out an all stores, all states model. And then I picked some pilot locations. And then I picked a time frame, and I was able to then review the accuracy of my predictions based on those particular places, those specific locations. And we said, hey, this process allowed us to optimize and replenish our store inventory by shipping the right product at the right place. It supported sales because the reps now had the right products to push in their stores. So they're going to sell more. So they're going to make more money. So this is going to support sales, and it's going to support inventory costs by eliminating that dreaded thing called stranded inventory. You're going to, number one, order the right amount of inventory for your warehouse. You're going to send the right amount of inventory to your different stores, and your customers are going to have what they need, and your salespeople are going to be able to sell more. So this was a great project, a great data science project for Telecom. So let me take a look real quick. I'm going to take a look at the chats. Maybe after your presentation, you can upload your slides. Yeah, I will. I'll actually work back with Amelia and see where we can load those slides. How many users at products were you dealing with? Oh, hundreds and thousands of products. So we're talking in the case of the global supply chain project that we did, we were talking about not just cell phones, not just our phones, but accessories as well. Thanks for pointing this out. So you're talking about thousands of different, the difference between, remember, it's the difference between, hey, are we going to sell a red iPhone 6 case or a clear iPhone 6 case? And that was one of the things that was really kind of presenting a problem. The cell phones themselves, of course, they're expensive and they present a problem, but we also had a problem with accessories being stranded, because guess what? After the iPhone 7 comes out, you're not going to be selling very many iPhone 6 cases because everybody's going to be looking for iPhone 7 cases. So what were some of the store demographics that we analyzed? We analyzed, now at AT&T, we pull our stores into marketing areas. So we looked at size of the store, store sales. So the size of the store, number of reps, size of their sales, how large their sales were over the course of time. And was there anything else? Let me look at the graphic real quick that we looked at. So location, store sales, number of reps, and store traffic. We looked at store traffic as well. How many customers have come into the store. So those are some of the things they that we looked at. Anything else? Any other questions? So I think I have a few more minutes, and there was something else. So that concludes that information, but there was one other thing that I did want to look at that I thought was rather interesting, and it's actually an article. And one of the things that was really cool in this article that they talked about was, some of the use cases around data science and in telecom is not just understanding how to push out products to our customers, but also, I'm going to stop sharing because I'm not sure if you see this weird screen, but I do. So there we go. So one of the things that was really interesting when I looked at this particular article, and the article that I took a look at is called, it's by Chungmin Chen, and I don't know what, it was done in 2016, and it was done in industrial technology advances, and it was around telecom big data analytics. And it was a great article that I really enjoyed. And one of the things that this particular author talked about is that the pieces that we need to look at in telecom include not just our mobile devices, but also and our networks, which I think we all focus on quite a bit, is our devices and our network, but also build in that piece of understanding and on the behavior and the sentiment and how our customers use our network, our products, our services. So I would suggest, if you have an opportunity, to do some research there. So you guys were able to see the nested mirrors. So I know that was really, really strange. I'm not sure why that kept happening. But so those are some of the great articles that I've seen around telecom and big data and telecom. And I wanted to see if there was anything else I wanted to show you, if you didn't have any additional questions. So one thing that I did want to also talk to you about is, and I had this question in one other presentation that I did, and it was, hey, how do I justify my project? Because big data projects takes a long time. They take a long time, and there's an investment there. It's time, and we all know, it's time, money, and resources. So how do you justify your project? So when I finished up that global supply chain project that I had, one of the ways that I had to come up with a calculation that allowed me to prove out that there was a monetary benefit, because let's face it, we want return on investment when we do these projects. So how do you take your big data projects and then build out your financial gains from these projects? So I actually didn't get approved to present this today, but I'm going to speak to it. So speaking to it, how did I come up with a calculation that I could then go back to my leadership and say, hey, this is beneficial, and I'm going to speak to it, since I didn't get approved to share it with you. But I looked at two things for that project. I looked at missed opportunities, and I looked at stranded inventory. And so what I did was I created a calculation, and I don't think this is telling anything, it tales out of school, if I mention a couple of ways that we look at stranded inventory and missed opportunity across telecommunications. We're going to look at days stocked out, right, under missed opportunities. And then I looked at my weekly sales, and then I multiplied that by the list price. And so this is how I calculated my missed opportunities. I said, hey, days stocked out divided by 7, that's going to give me my daily missed opportunity. And then I multiplied that by my sales forecast. And then I multiplied that by my list price. And when in this particular case, 1 week, based on my model, predicted that we missed out on over $1 million worth of opportunity. That was just 1 week with the products that I looked at. So that's how I was able to go back and say, we have a missed opportunity because we're not using my model of $1 million a week. Then I was able to go back and say, now let's talk about stranded inventory, because stranded inventory wasn't initially my purpose for this project. But once I got into the project, I realized that I had an opportunity there as well. And so how do I say there's an opportunity for stores to reduce their SKUs at risk? And so I then said, okay, let me take the SKU list price and let me take the times the store on hand. Okay. And then multiply that out by 12 months. And these were for the SKUs that I specifically said were shouldn't have been in the store. Okay. So the sum of the SKUs list price multiplied by the store inventory on hand, multiply that out by 12, and annually. And I even said, okay, I'm not even going to say I'm 100% accurate. I'm going to say 75% accurate with about 20% corrective action. And if you in supply chain, you know, corrective actions means we've already, marked it down, tried to get it out, given it out as a prize when you buy something else. So that's what corrective actions means. So even with 75% accuracy and 20% corrective action, I was able to go back and say, using my model, you'll now be able to save $2.1 million annually just on your stranded inventory, reducing the risk of stranded inventory. And that's big. And that was just on this small pilot. Remember the pilot, I don't know that I mentioned, the pilot was just 3 stores. You can multiply that out to all your stores. And at AT&T, we have over 2,000 stores. So when you start building out those calculations, that's how you start getting to the nitty gritty of how do I take this data science project and build it into revenue generating, revenue saving opportunity for my organization. So that's how we can get to the good stuff in telecom. Any questions about what I've gone over so far? Because I think I have, I don't know if Amelia's on, but I think I have a few more minutes. Let me check my calendar really fast and see how much more time I have. But I do believe, okay. So I have 15 more minutes. So thank you for that. I have 15 more minutes. Does anyone have any questions around how you do these calculations? I will tell you, building out the calculations was interesting. I will admit that there was some going back and forth, especially on the stranded inventory, because I was not comfortable, and this is something you'll have to work out with your leadership. When you do these data science projects, one of the things that I had to educate my leadership on is that these are predictions. They are not we can't go back and say, if you do this, you're definitely going to get this result. These are predictions, and it's just like the lottery. Sometimes you win, sometimes you don't. And so that was one of the things that I struggled with. One of my leaders wanted to put a lot of this in a business case, and I wanted him to use the correct wording when he used the business case, that these were predictions, that we were looking for this to happen, but not necessarily that these were solid numbers. And but they were good directionally. So I see a question. How do you manage machine learning OPS? What do you mean by OPS? So is this the Are you talking about from a platform perspective? So I'm not sure what OPS stands for. Um, Atif, if you could elaborate on that. And then Praveen, how do you manage ROI for, operations? Okay. I'll come right back to that one. So how do you manage return on investment for data science projects? Honestly, it's a slippery slope. So the slippery slope there is my calculations that I was building out was being put into a business case for building out return on investment, right? So that was a business case that was going up to finance. So there is a little bit of slippery slope on, how fine you want to use your predictions. Because remember, these are models that build out predictions that you're now putting dollars to and saying, hey, if we do this, we feel like we could save X amount of dollars. But what I really believe in is a quarterly check-in on your models. So when you use your models, I believe in a quarterly restating of your models until you get those models fine-tuned. And so that's pretty much how I do it. That's kind of a little half answer there, in the fact that yes, we try to build out a calculation. Yes, we build it into our the financial part of our business plan, our business cases. But at the same time, you have to revisit it. You have to refine that, because the models have to be revisited and refined as you get more data, because things do change. So thank you for operations. So deploying of models, really great question. So today we do this. Thank you, Phyllis. So today, when we deploy a model, we have a team that builds out the model, and we deploy the results of that model into our ecosystem, so into our platform database. I own a database called Copernicus, and that in Copernicus, I have several models that we load on a monthly basis, or whenever those models are refreshed, we load that data into my platform. And that allows people to be able to leverage the model and the model output for other things. One thing you can't do is build your models and have it sitting on your desktop. You've got to load it into the ecosystem so that other organizations, other teams are able to use that model. The other thing that we are doing is, I mentioned that Atlantis project, or feature store project. The cool thing about that is that we're able to push data two ways. So push data into the model, into the feature store, let people use it to build out models, and then we pull that model results back into our ecosystem so that we can now use it in, other analysis. So that's pretty much how we do it. Now, the piece that I didn't clarify there, and you probably caught it, is where are those models housed? Today, they are housed with the people who build the model. That's the truth of the matter. In the future, we are building out great infrastructure at AT&T in the cloud and Snowflake to be able to have our models live in a place that everybody can get to. But today, they live with the individual people that make those. Well, interesting comment, Fatima. COVID, I'm not saying that COVID was good, but there were some good outcomes because of how we had to, as a organization, whether it's AT&T or other organizations, we had to come into the new world, right? We had to produce some things that were new, that maybe new to us, but weren't actually new to some other folks. And I'll give you an example. Sure, Atif. An example was, we had to close down a lot of our retail stores. So we still needed product because people were still living, right? People were here and they needed our product. But how we distributed those products changed. So we had all this product sitting in the stores, but the stores were closed. So what we had to do was we had to create a way to now deliver those products directly to our customers efficiently. because we always had a process that you could order a cell phone and get it delivered to you at your home, but it wasn't very efficient. So we had to really build that up, build that project up, and we had to do it really, really fast. And so we did do that. I apologize for the yard people outside if you hear that. Um, so, how did our modeling approach change? I'm going to be honest. I think our modeling efforts stepped up. I don't think that they changed, other than we now are doing more modeling than we were before, because we need that information. And we need that information so that we can be more prescriptive about where we're going and how we're touching our customers. As far as implementing something as a safety net for the future, we have implemented a lot of new processes at AT&T, and I think many organizations have, because guess what? I don't think curbside service is going away. I think we're going to keep on seeing curbside service, because guess what? It is awesome. I love the fact that I have a Chick-fil-A app that lets me order my food before I get to Chick-fil-A, and I don't have to sit in the Chick-fil-A line anymore. I can go park and wait for someone to bring me my food. Those are the sorts of things that I think have changed, and not just telecom, but across all industries, that we now have to do. Now, as far as modeling is concerned, I think now we have a new piece of data to include in our modeling, and that's the people who not only want to go in, curbside groceries or delivering groceries to my house. Thank you very much. It used to just be for shut-in people. Now everybody's doing it, and online shopping, exactly. But here's what happened because of that. We now have a new data source, don't we? And we have a plethora of that data. We have to now build that data into our new models, or our old models, and build new models based on that new data, because now that's a new avenue of servicing our customers. And now we have new products for our customers and new services for our customers. Lauren says she needs to place her Amazon Fresh order. But we have about 5 more minutes. I'm going to keep on talking until we run out of time. But I want to be cognizant of the other presentation, so I don't want to go over. But this has been a very fun conversation. Thank you so much for the input from the chat. But yes, these models, building out these models within telecom, there's so many great ways to use modeling and data science in telecom. And it's growing, like Fatima kind of suggested. There's this future that we're now looking towards, and we're now building towards, that we always had a future we were looking towards, but that I don't think that future was as far as it is now. We're looking further out now, probably in the robots run the world arena versus, let's look out a couple of months or a year. So I agree, Fatima. I believe we are now looking outside of the box. We're innovating. And here's what I would also say. We're innovating fast. Like in the past, we would have a project, kind of, we got this project and we're all working on it. Now we need to get these things out fast, because we need to service our customers differently, and we need to do it quickly. And I saw that during the first few months of the pandemic. Man, I was part of a huge project on returns. So in telecom, we have returns. So if I want to upgrade my cell phone and I need to return my old cell phone, how that process we had in place. But now we had, instead of people being able to also drop their phone in, hey, Laverne, yes, getting phones back now, I think our process now is next day delivery for all delivery of phones, which is so cool. But we had to create this process of returns that leveraged our old process, but expanded it, because now everybody had to return the same way via, UPS or however we were doing it. And you couldn't go in and drop your phone off in the store. But here's the other thing. We needed to be able to do this fast, because people were relying on their technology. People were using their technology to go to school. They were using their technology to work. and they didn't have time to wait 2 days to get their new phone, their new computer, their new iPad, whatever that might be. So we had to innovate and get quicker at delivering. So I think it, like I said, of course, the pandemic, I don't know about you, but I'm ready for it to be done so that I can get back to traveling like I like to travel. But there were some some positive things that we were able to build out of necessity. And I can't remember the really cool phrase. Necessity is the mother of all invention, I think is the phrase. But the yeah, at Fatima. So yes, there invention, innovation, that is very important right now, and we're seeing it, and I'm loving it. I'm loving the way that we are inventing and moving ahead, and being able to service our customers with products and services. So I have about 2 minutes left, and I think that's it. But I was so happy to have this opportunity to work with you, talk with you, provide my insights on telecom and data science. And I hope that it was beneficial. I hope that you enjoyed it. And I hope that you delve into the arena, dive in, start working, working those projects. Okay. Thank you. Thanks, Timothy. Great, Fatima.